Okay, lesson 94 is a second look at uniform motion problems. The time we did them in lesson 92, they were equal distances, and people made the same trip, people did a round trip, they went somewhere, came back, that kind of stuff. This one today, we're going to have a situation where the two distances add up to something. All right. So the same deal as lesson 92. The first thing I want to do is read the problem carefully to get an idea of who's going in which direction and do I know any distances. I don't care about speed or time when I'm doing this. I just care about distance. So I have a southbound bus leaving Fort Walton Beach at 9 a.m. 2 hours later, northbound bus left the same station. So just looking at that first two sentences there, I got Fort Walton Beach is right here, the bus station. I got one bus going south, some unspecified distance. So I'm going to put d sub s to represent the distance the southbound bus would have traveled. I have a second bus going north, an unspecified amount of distance, so I'm going to draw an arrow going up representing the northbound bus. Okay. No words in the words I've read imply that those distances are equal to each other, that they just went some distance. So they're moving in a direction. This one's going south, that one's going the opposite direction, north. And it says the buses traveled at the same rate, we're 352 kilometers apart at 2 p.m. So, again, I'm focusing on distance only when I'm drawing this picture. 352 kilometers apart. That means the ending position of the northbound bus and the ending position of the southbound bus is 352 kilometers. So based on that picture that I'm looking at, I don't know how far the northbound or the southbound bus went, but short segment plus short segment equals long segment, so I know that the northbound distance added to the southbound distance is equal to the total distance traveled by both buses. And again, that's priority one of these problems. Do not try and do anything else until you've figured out how the distances relate. And again, at no point in time did I care about what time they left, how fast they're going, anything like that. All I care about is how far do they go. This one went south, I don't know how far. This one went north, I don't know how far. So I've used variables to represent them. And just like before, I'm using d sub s, d sub n, d for distance and subscripting to make it meaningful. So anything about the southbound is sub s, anything about northbound is sub n. The categories in this chart are still going to be rate, time, and distance along the top. And the two categories in this, that we have bus going south, bus going north, so let's still go northbound, southbound. That's south and north. Okay. Once I've done this and figured out this distance relationship and made this equation with distances, the next thing I need to focus on specifically is rate and time. How fast are they going and for how long are they doing it? So these two boxes, or these four boxes I should say, need to be filled in with something. So I start reading the problem again. I'm looking for specific speeds, specific times. Okay? So, does it say anything about how fast they're going?
No.
Nothing at all.
Besides them going the same.
The same. Okay? They don't tell us what the rate is, but they're going the same rate. Okay, that means we don't know it, but we can use the same letter to represent both. So if I use R for the rate of the south bus, I can use R for the rate of the north bus. Okay. Another way they might put that, they might say one bus was faster than the other bus by 10 miles an hour, so R plus 10. One bus went twice as fast as the other bus, R and 2R. So they're going to give you some type of relationship to be able to use the same letter to represent both things. Since I used a variable in the rate box means I have to know the times. Now here's one thing you have to be cautious of. They're giving me time of day. The southbound bus left at 9 a.m. The northbound bus left 2 hours later.
Which is 11 a.m. I mean, yeah.
All right. And the buses were 352 kilometers apart at 2 p.m. All right. When you're looking at a time, like a p.m., a.m. time, that's not what this is. I don't want to put 2 and 9 or 9 and 11, whatever. I don't want to put what time it was on the clock here. This time is how much time passes. So if we're looking at the southbound bus, it started at 9 a.m. and at the end of the problem was 2 p.m. That's a total of 5 hours.
And the other one's
And the northbound bus left 2 hours later. That's 11 a.m., right?
3.
11 to 2 is 3 hours. So we have the ability to find the correct elapsed time. And again, it's very careful when you start seeing time of day that you don't put 9 and 2 or anything like that. you get the how much time passed on the clock. Okay? What type of rates are they? What unit? Kilometers per hour, right? So times in hours, distances in kilometers. Right? If you want to put units in your chart, that's where you want to put it. Don't put it in the boxes. Keep the boxes just to letters and numbers. I'll put the units up here so they're not in the way of everything else. Once I get these 4 boxes filled, either with variables representing things we don't know and numerical values representing things we do know, rate times time equals distance. So R times 5 is 5R for the distance traveled by the southbound bus. R times 3 is 3R, the distance traveled by the northbound bus. And the distances are the things that we have over here. So the northbound distance of 3R out of the southbound distance of 5R is equal to 352 kilometers. And we solve this equation, it's going to be 8R is equal to 352.
And it's
Divide, what do you get, Mitchell?
44
44. 44 what?
kilometers per hour,
Very good. How do you know that?
because that's what the rate is. And that's what
R equals 44. R's are right here in these boxes on the category of rate, which is kilometers per hour. Okay, if they're asking me how fast the buses went, I'm done, right? The question says find the rate of the buses, so I'm done. The other thing they may have asked me is how far did the northbound and the southbound bus travel? If they asked me one of those, I'd have to figure out that. Multiply 44 times 3 or 44 times 5. They asked for the speed of the buses, and the same, so 44 is the correct answer.